Hello, everyone. In this lesson, we continue our discussion on the fundamental theorem of calculus. In today's lesson, we will be focusing on, more specifically, the FTC 1. Let's look at the following problems. Evaluate the integral from 1 to x, 6t squared minus 2t plus 3 dt, and determine d dx, integral from 1 to x, 6t squared minus 2t plus 3 dt. The integral from 1 to x, d is 6t squared minus 2t plus 3 dt. We can recall our integrals for power functions, which is this exponent, you add 1, and then also divide by whatever the exponent you would have up here. So like 2 plus 1, and then divide by 2 plus 1. So then that'd be 6t to the third divided by 3. So that gives you 2t to the third. This other one minus 2t, that becomes t 1 plus 1. So that's t squared over 1 plus 1, which would be 2t squared over 2. So that gives you t squared. And then apply the same rule to the 3. So you're going to have t 0 plus 1 over 0 plus 1. So that leaves you with plus 3t. Over the right side, you just straight line down, and then you put your x to the top, and that x is your upper limit. It's not an exponent, it's just your upper limit. And then to the bottom, you have your 1, which is your lower limit of integration. That's your limit of integration. And then we're going to evaluate it. This function, 2t squared minus 2t cubed rather, minus t squared plus 3t evaluated at x. And then from that, we subtract that 2t cubed minus t squared plus 3t evaluated at 1. So imagine that there's a minus sign between these two things, or f of b minus, or f of a uppercase f of b minus uppercase f of a. And then so this will be equal to your 2x cubed, because you plugged in x with t, minus x squared plus 3x minus 2 times 1 cubed minus 1 squared plus 3 times 1. And so that gives you equal to 2x cubed minus x squared plus 3x minus 4. And so that is your antiderivative for that function evaluated between 1 and x. Part C, we take in d dx, the integral from 1 to x, of 6t squared minus 2t plus 3 dt. Now you can imagine something like the d dx somewhat undoing this integral, derivative undoing this integral. So what is left inside here would be a function 6t squared minus 2t plus 3, and then it'd be evaluating it at x. Okay, so this becomes your f prime, your uppercase f prime of x, because this was your antiderivative, uppercase f prime of x, derivative of the antiderivative f prime of x, uppercase f prime of x equals 6x squared minus 2x plus 3. And that is your lowercase f of x. If you go back to looking at what the f of x, if you took the integral of this, you would have got that. So if you take the derivative of the uppercase f of x, that gives you your lowercase f of x, where uppercase f of x was your antiderivative of your lowercase f of x. Let's look at another problem. If g of x is equal to the integral from 1 to x of 6t squared minus 2t plus 3 dt, determine g of 2 and g prime of 2. Now, recall that this integral from 1 to x of 6t squared minus 2t plus 3 dt, we had already worked out what those g primes, something looking like the g primes and the g of x, the g of x look like. So let us just go back to doing that. What was the antiderivative of that function that we worked out to be equal to 2x cubed minus x squared plus 3x plus 4. So then the g of x will be the g function evaluated at 2. So wherever you see x, you plug in 2. So that g of 2 will be equal to 2 times 2 cubed minus 2 squared plus 3 times 2 minus 4. All of that will be equal to 14. Now your g prime of 2 would be whatever your inside function was there, which was 6 t squared minus 2t plus 3. So that's going to be, we'll replace that with 2. The x would become, like we plug in the 2 for t, that would be where the x would be. So 2 goes right there wherever you see those t's. So 6 times 2 squared minus 2 times 2 plus 3, and then that will be equal to 23. Okay, now use FTC1 to determine d dx, the integral from 1 to x of t squared times the square root of 1 plus t squared dt. And also, if g of x is equal to the integral from x to pi, integral square root of t sine of t all raised to the 4th power dt, determine g prime of x. Determine g prime of x. Fundamental theorem of calculus 1. You can remember that the derivative of the special integral is going to be this integrand evaluated at the x. So then the t squared square root of 1 plus t squared dt, all of this will become x squared square root of 1 plus x all squared, and we're done. So the fundamental theorem of calculus makes it very easy to solve a problem like this. Or if you want to think of the derivative of the special integral function, these two, if you want to think of it that way, in a very short way, that these two undo each other, and you're left with this. Okay, evaluated at x. Right? There we go. The g of x is equal to integral x to pi of square root t sine of t all raised to the 4th dt. We can rewrite this as g of x is equal to negative of the integral from pi to x of square root of t sine of t raised to the 4 dt. And now the g prime of x, you've taken the derivative of the special function, so that's the ddf, the negative of it, pi 2x of square root of t sine of t raised to the 4 dt, and so that's going to be the negative of this inside function here, negative root t sine of t raised to the 4th power. And because we evaluated at x, these t's now will be x's, right? So it's going to be now negative square root of x sine of x all raised to the 4th power, right? There you go. Thank you so much for watching. Please like and subscribe, and see you next lesson.